Hello everybody, today I'm going to solve problem 2.3 from our thermodynamics book. So it's divided in 7 parts and we have 50 flip coins. So we have part A that asks how many possible outcomes are there? Well, in order to find this, we just need to take the possible outcomes. So for example, we can either have heads or tails. So there's going to be 2 outcomes. And then it's power of n, or the power of the number of flips. What are the number of flips? There are 50. So the possible outcomes is 2 to the power of 50. Part B then says, how many ways are there to get exactly 25 heads and 25 tails? Well, in order to do this, we just need to find our formula for the number of microstates, which is 25 and 25, omega 25 and 25, which is equals to, 50 and 25. Yeah, I want to say 50 and 25, yeah. So we'll have 50 factorial over 25 factorial times 50 minus 25 factorial. Oh, factorial outside differences. Where does this formula come from? Well, this formula comes from omega of n cubed, where n is the number of particles, or in this case of uh, coins flips, and q instead is the number that we want to obtain. In this case, number of heads or tails, depending on what you want to find. So we have n factorial over q factorial over n minus q factorial. So here we get 50 factorial over 25 factorial times 25 factorial, which is equals to 1.26 times 10 to the power of 14. And these are the number of ways we can get it. Part C instead just asks, what is the probability of getting exactly 25 heads and 25 tails? Well, in order to do this, the probability is equals to our omega of nq over our omega of all. So it's equals to, we said 25 heads, 25 tails, so omega of 50 comma 25 over omega all, which is 2 to the power of 50, because we have 2 to the power of 50 combinations. So this is equals to, we just had on top 1.26 and 10 to the power of 14. I'm just going to run this over 2 to the power of 50. You can just plug it inside the calculator and we obtain 0.112. This is probably getting 25 heads and 25 tails with 50 flip coins. Right. Now part D says, what is the probability of getting 30 heads? So again, probability is going to be equals to our omega of 50 comma 30 over probability all. Now, one thing that you can notice is that here we're talking about 50 heads, but what if I wanted to just say 30 tails? Well, I would actually get the same thing. I'm going to prove it in a second. So I'm just going to say this is equals to this part over here. Alright, so from the top we get, 50 factorial over 30 factorial times 20 factorial over 2 to the power of 50. And the bottom here we get 50 factorial over 20 factorial times 30 factorial over 2 to the power of 50. As you can see, we get the same exact answer. That's going to be equal to 0.042. And of course, the same thing over here, 0.042. Part E. Part E is talking about what is the probability of getting 40 heads. So probability again is equals to our omega of 50 comma 40 over beta all, which by the way is equals to the same thing again. If I said, for example, 10 tails instead of 40 heads, I will get 50 factorial over 40 factorial sometimes factorial over 2 to the power of 50. And this one will get 50 factorial over 10 factorial over times 40 factorial over 2 to the power of 50. And again, these are the same exact thing. I obtain 0.000091. Okay, so now here we have f, and what's probably getting 50 tails? What's gonna be equals to, again, 50 comma 50 over all, and again this is again equals to 50 comma 0 all. So here we get 50 factorial over 50 factorial times 0 factorial over 2 to the power of 50. And at the bottom here we get 50 factorial over 0 factorial times 50 factorial over 2 to the power of 50. And here again we obtain 8.88 times 10 to the power negative 16. And then part E asks to graph it. I'm just going to do a quick graph, not perfect, but it gives the idea. So we're going to have our center on here where we're going to have 25 heads or 25 tails, that's where we're going to count. And then we're going to have 0 heads, 0 tails, doesn't matter, even though we're going to get something like this. Actually, it out pretty well. Yes, and this is the final solution to this problem.